I've been building stuff since I was a kid, which has led to me eyeballing a lot of my props and projects. Eyeballed it. Eyeballed it. Eyeballed it. Eyeballed it. Eyeballed that one too. Eyeballed it. Now I'm trying to break that habit, so today let's have a look at some basic math that's going to let us quickly and efficiently scale our projects. Welcome back, guys! So today I am going to talk about scaling. I mentioned in my last video I was going to talk about the scaling on my Reach turret. I decided to make a full separate video, show you guys start to finish how I scale props. So, I'm really bad for eyeballing things. However, on the Reach turret, I wanted it to be like true to size, true to real life, true to game size, true to real life size, true to real life size. Yeah. So, let's start from scratch here. So you're going to want a calculator. You can use your phone, just fine. You want a ruler. The more accurate, the better. And some sort of pencil. Actually, pencil's better for this. Pencil. So I'm going to be using a Sharpie just because it's easier to show you guys. So we need something to reference off of to start. So luckily, a lot of video games have expanded universes where they tell you the size of things. For example, Halo has a huge following for the expanded universe, so you can look it up online. You can find like the actual sizes of the weapons in it. So in this case, it's 163 centimeters long for the turret. Let's say we don't have that. Let's say we just have a guy. He's got a sword, he's got a shield. You want to make the sword and the shield. In the event that the guy is an actor in a movie, luckily we can just look it up online. You can find the heights of most actors and stuff online. That gives us a good reference point. Otherwise, you might have to just do a little bit of guessing there. If it's a character in a video game, you might want to reference off of other characters or just other things in the world just to get an idea of the size for it. So in this case, let's say he's an actor in a movie. We know his height. He's 6'3". So, unfortunately, inches and feet don't work well when you're scaling. It's a lot easier to work in decimals. So we're going to do everything in centimeters and millimeters. I guess millimeters is the more accurate way. So 6'3" in millimeters is 1,905 millimeters. So those are our starting points. What we want to find is what 1 millimeter on the screen, millimeter, or on our sheet here is equal to. So the way we're going to do that, we're going to find our guy's height here in millimeters. So it looks like he is 94.5 millimeters tall. And we want to find, I keep doing meters, there we go, millimeters. And we want it to correlate to being 1 millimeter on the page. So we're going to say this is equal to, that's right, 1,905 millimeters. And we need to find what that 1 millimeter correlates to in real life. So we got our sheet size of the guy, but we want to find out what 1 millimeter is. We've got the height, real height of the guy, and our variable there, the x. So just going to do a little basic math. So we got 94.5 millimeters times x is equal to 1,905 millimeters. Oh, I goofed up there again. Millimeters. So, x is equal to 1,905 millimeters divided by 94.5 millimeters. So, x is going to be equal to 905 divided by 94.5. So I'm just going to round up to the nearest decimal point there. So it's going to be 20.2, I keep goofing that, millimeters. So what we have here, this x value, anything, well, it's really easy actually. All we have to do now is multiply 1 millimeter on the page is equal to 20.2 millimeters in real life. So 1 millimeter, this is our scale, is equal to 20.2 millimeters. So let's take our, we got our guy's height there. So let's say we want to know the length of his sword. I'm going to measure out, I'll just section that off there. So let's say we want to know the height of his sword. I'm going to get on there. I want to be as accurate as I can. That's going to give us the best read. So it looks like it is 61 millimeters long. So from here to here, 61 millimeters. So, real simple. 61 millimeters, whoops, times 20.2 is equal to 1232.2 millimeters. I'm really struggling with that. So that's the length of our sword, which is 1.2 meters, or you can just go off the millimeters. So awesome, we know the length of our sword. We can even go further, find the width of the hilt, length of the hilt here, how long like the blade is. So you can use that exact same formula for everything, just multiply it by 20.2 in this case. So if we were to go like that, we would find out its length of the blade is 43 millimeters. Which again, times 20.2. $868.6 millimeters. So just shy of a meter long on the blade there alone. So I hope that makes sense. And again, you can use that for the shield. You can measure the height, the width. Ideally, that's a perfect silhouette. So, all right, let's get into the Halo stuff. Stuff I was initially talking about. So, luckily, Halo gives us a reference size on, I think it's halopedia.com, something like that. Look things up online if you can find the size, or the size of it in, again, quote unquote, real life. Look it up online. Otherwise, you do have to make some guessing. So in this case, keep in mind that everything's going to be a little bit different in scale. You can't just take the... So, I found this scale already. It's 1 millimeter on the page is equals 7.1 millimeters in real life. So, let's look at this piece here. Obviously, this is a lot closer up than this. So on this picture here, because this little box is an angle, like sitting at an angle there, I can't really tell what the length and the width of it are. So we go to the another angle here, and again, I'm trying to get as close as I can to a straight silhouette. I know it's tough, especially in video games, taking a screenshot or something. But let's go to this guy. So we need a reference point here to start at. So I do have a bunch of different angles from different things. So using this page, I was able to get enough reference points to get another scale at a different angle. So from the front here, I was able to determine that the width of that blast shield is 660 millimeters. So that gives us a good starting point. So 660 millimeters. Apologize, that's hard to see on screen there. From there to there. That should do. So going off these corners actually isn't going to work for me. Because if we look at this, just due to the angle I've taken this picture at, everything's hitting a bit of an angle. The top is wider than where the bottom would be. So if we were to extrapolate, that guy would sit kind of down like so. So I want to measure roughly on the plane of everything else, which is going to be sort of near the bottom of the blast shield. So we're going to measure off of right here, which, as you can see, everything is straight at that point, which is perfect for us. So I'm going to take a reference point here, reference point right on that corner there. So that's my 660 millimeters. Whoop. Breaking stuff. So yeah, keep in mind all the angles you take your screenshots at. So I'm going to go on here, determine that is 125 millimeters. Yeah. All right, so we got. Maybe I'll do this with the Sharpie so you guys can see. No, other Sharpie. Do this with the Sharpie so you guys can see. So we have 125 millimeters, and that is equal to 660 millimeters in real life. So again, I want to find down to the millimeter. Get our x value in there. So we get 125x equals 660, because again we're cross multiplying. So x is equal to 660 divided by 125. X is equal to 5.28. So I like on all of my, you'll notice on each one of my sheets I marked down in the top corner 1 millimeter on the sheet. It's equal to, well in this case 5.28. Let's just go 5.3. We'll round there, it'll be close enough for a prop on the scale. So 5.3 millimeters. So now it's nice and easy. If we want to find the size of our little angle box there, just going to take a reference off the top there. So it looks like we got 12.5 millimeters in that direction. Times 5.3. And we get 66.3 millimeters. It's the length of our box from right there to right there. So the awesome thing here is you can go along, you can find all kinds of different reference points for your size. Like I'm right down to the little louvers or holes there in the barrel shroud, and you can go find literally any size you want, or any, you can literally find any dimension you want for the parts you want to build. I hope that wasn't too convoluted, guys. I hope you understood most of it. I'm not a math teacher. If you guys enjoyed this, please be sure to hit that subscribe button so you can see my future videos, and hit the like button too if you enjoyed it. We'll see you next time.